Welcome, nanotechnology researchers. My name is Jan Udy, and I am the Social and Ethical Implications Coordinator for the Southeastern Nanotechnology Infrastructure Corridor, or Senic, which is a user facility site at Georgia Tech and the Joint School of Nanoscience and Nanoengineering, or JSNN, which is an academic collaboration between North Carolina A&T State University and the University of North Carolina at Greensboro. Senic is part of a national network of sites funded by the National Science Foundation called the National Nanotechnology Coordinated Infrastructure, or NNCI. This presentation is about the 8 things to know about the social and ethical implications of conducting research, including fabrication and characterization, and of working on commercial or commercializable products. The first thing to know about the social implications of conducting nanotechnology-related research at this facility is to take care of research compliance and safety requirements. If the research you are conducting involves human subjects, animal testing, or DNA or stem cells, your research will need to be reviewed by your institution's Office of Research Integrity or Compliance. If you are a student conducting research sponsored by the National Science Foundation, National Institutes of Health, or the U.S. Department of Agriculture's National Institute of Food and Agriculture program, you may have to take responsible conduct of research training. On the safety front, you will need to go through the facility's safety training to ensure that you know how to safely operate the equipment and instruments at your facility, including chemical safety, personal protective equipment, electrical hazards, chemical fume hoods, and X-ray radiation safety. If you are not sure about these requirements, reach out to your professor if you are a student, a facility contact, or a member of your institution's Office of Research Integrity or Compliance. The second thing to know is that you will likely be working on something different from the other researchers in the facility. This is because nanotechnology is what is known as a general-purpose technology. It enables improvements in technologies in diverse fields. For example, nanotechnology has application for materials, energy, medicine and biotechnology, and electronics. The National Nanotechnology Initiative, which coordinates federal research and development across multiple agencies, says nanotechnology is science, engineering, and technology conducted at the nanoscale, which is about 1 to 100 nanometers. So you can see that this definition encompasses a lot of diverse areas, and there may be extensions into biomedical or micro-level research above 100 nanometers. The upshot is that there is great diversity in research conducted under the nanotechnology umbrella, so take the opportunity through the facility's speakers programs and networking events to find out about what others are working on. The third thing to know is that even though your research is conducted in a lab or clean room, it is likely, if successful, to connect to or be integrated into an application that's already out in the world. One thing we know about technologies already in existence is that people's behaviors are influenced by technologies, and technologies are influenced by how people use them. You never know how people will use your research and how your research will affect people's behavior. One example of this is Benny the bear, a nano-silver-coated plush bear which had antimicrobial properties. Great for keeping the stuffed animal clean, but babies are going to put toys in their mouths, and that resulted in the bear being pulled and the coating being changed. So you have to think about how your research relates to the world outside the lab or clean room. The fourth thing to know about the social implications of conducting nanotechnology-related research has to do with the broader impacts of your research. Many governmental funding agencies ask the researcher to think about the societal problems that their research can solve. Case in point is more environmentally friendly formulations or treatment for diseases. But the thing is, you want to make sure that there isn't an overreaching of the social implications of the work or overlooking of issues that can limit the potential social benefits. Some research is likely to be more closely linked to societal needs than others. Research related to nano-enabled solar cells, nanogenerators, or zeolite nanocomposite reverse membranes have a direct connection to green and sustainable development. In contrast, synthesis and characterization of graphene, while important for subsequent applications, may lack the specificity to make such direct connections. Care should be taken in thinking about the contribution to societal goals in these cases. A second example of this is research into a new type of nano-enabled solar panel. On the surface, this could be viewed as an energy-saving application, but by using life cycle assessment, which pays attention to a full cycle of cost from the extraction of resources through production, use, and recycling up to the disposal of waste, you can see that some of the materials used, like single-walled carbon nanotubes, can require a lot of energy to be produced. Others, like quantum dots, may use materials like cadmium and selenium and may, under certain conditions, release toxic compounds in use or on disposal, even as they may require less energy in displays. Another example is that some nanotechnology research, such as using nanotechnology for water purification, is targeted to lesser developed regions. The thing is that there is a history of applications that have failed in these regions because these regions lack the infrastructure, human resources, and supply chains to support the applications. Most lesser developed regions have needs that extend beyond a particular technology, so you will need to pay attention to these cultural and historic needs. A fourth example is the use of rare earth nanoparticles, which are important in biosensors and bioimaging. These elements are not rare in abundance, but are difficult to extract and process. There are geopolitical conflicts over access to these elements, including trade disputes and export restrictions. You don't want your ability to meet broader social implications of your research limited by overreaching, lack of attention to toxicity and energy use, issues with lesser developed regions, and concerns over rare earth materials. The fifth thing to know about the social implications of conducting nanotechnology-related research is that if you truly want it to have commercial value, you need to identify what is new and different about your possible product or application. What is the technical specification that makes this application unique? What problem does this technology solve? How is this solution better than the status quo? An example is a technical specification that a nano-enabled device is portable and can be taken in the field rather than only being able to be used in the laboratory. If your work has been funded under an NSF grant, you may be eligible to apply for NSF's Innovation Corps, or I-Corps, a commercialization boot camp to learn evidence-based entrepreneurship methods for starting a science-driven venture. If you are interested in attending an I-Corps workshop, please discuss the commercial readiness of your effort with an NSF program officer. There are also Small Business Technology Transfer, or STTR, research grants that enable prototyping work in a partnership between a business and industry. Different local organizations also offer seed grant programs to pay for further research, including covering the costs of equipment and facility use. The sixth thing to know is that you need to think about who the customer for your product or application might be. Who might think this work is valuable? Much nanotechnology work will be sold to corporations who will integrate the application for the end customer. Even if these corporations are few in numbers, such as an energy utility company, you still have the units within the corporations. While it is important to think about early adopters of the application, attention should also be paid to major societal groups. The first is government agencies, foundations, and non-governmental organizations. The second is underrepresented groups such as underrepresented minorities or those who are physically or economically disadvantaged. Cancer treatments might be very useful but unaffordable to economically disadvantaged groups, which is the more care for fewer patients problem. The third is groups who might lose their jobs as a result of your research. For example, window washers may not be needed with nano-coated self-cleaning glass. It may be too much to expect you to solve this problem, but at least you should recognize and reflect on what happens to those who may be displaced. The seventh thing you need to think about concerning the social implications of commercializable nanotechnology-related research is who might be a good partner to help bring your work to market. Government agencies can provide resources through public procurement of innovative goods. The biggest example of this is the Small Business Innovation Research, or SBIR program, which includes the STTR program I mentioned earlier. Government agencies will post different solicitations for SBIR or STTR proposals at different times during the year, so you want to pay attention to these. Government agencies also set standards and regulations so they can be good partners to help you get your application to market. Nonprofit organizations can also be good partners. Not all potential partners are supportive, however. Some might oppose the technology. For example, the International Union of Food, Farm, and Hotel Workers called for a moratorium on nanotechnology in food and agriculture in 2007 until toxicological and socioeconomic risks were better understood. Allowing for public participation and comment on issues that are likely to be sensitive can be helpful here. The eighth thing to think about is regulation and labeling. In the U.S., most nanotechnology-related regulation occurs under existing statutory authority or non-binding recommendations and guidance documents. There may be differences by state or city, especially for reporting of nano-related research activities, so those should be monitored. And regulations are different in different countries. As to labeling that communicates the presence of the emerging technology is important for transparency in both an ethical sense to communicate risk and an economic sense to give the market full information. Yet many features do not lend themselves to drawing a line dividing existing and new technologies, and labeling is not easily monitored by government regulators or non-governmental organizations. One example of a labeling issue is the Samsung Silvercare washing machine, which originally used the term kill bacteria, but the U.S. Environmental Protection Agency deemed that this labeling would regulate the product under the Federal Insecticide, Fungicide, and Rodenticide Act, so Samsung changed its labeling. Although labeling may be in the future, you should reflect on these issues as commercialization activities progress. So those are the 8 things to know about the social implications of doing nanotechnology-related research. If you want more information, please go to senic.gatech.edu or nnci.net.